So, good evening my dear students. Now, we are going to discuss direct form 1 realization. So, from the previous section, we got that the transfer function of the filter h of z. From the h of z, we are going to implement the filter in direct form 1. So, please listen carefully how it can be implemented. That is practically how it is possible. The filter is doing just it is a multiplication and addition, that is called as convolution function. How it can be implemented? Please see that. First, you see the numerator is having 2 delay elements. Z power minus 2 is the maximum. You see the maximum number of delay elements are available in the given transfer function. Here it is 2. Denominator also you see that how many number of delay elements are there. So, here also maximum delay element is Z power minus 2. So, in the input side as well as input side and as well as output side, you put 2 delay elements. That is the first thing. Then we are able to construct the filter. Okay. So, I am construct the filter, you see that. This is x of n or x of z. Both are same. Time domain it is x of n and frequency domain it is x of z. Okay. Then you see that 3.6 z power minus 1 and 0.6 z power, only 2 delay elements are there. So, I put this is the first delay element and I put a second delay element. Only 2 delay elements are available in my design, right. Okay. Now, implement it. So, 3 is a multiplier, right. It is having x of n, the input is directly multiplied by 3 into x of n. Then next you see that 3.6 into z inverse. So, this is x of z inverse. So, z inverse it is also x of n minus 1, both of same, right. Please students listen here, x of n is your current input, x of n minus 1 is your previous input. So, for the previous input you are able to store it in the memory location. So, x of n, suppose next input come means current input is coming here, then next input coming means the current input is go this way and then it is go, it is now it is x of n minus 1. Then next another input coming means that is x of n, that previous is x of n minus 1 and previous power that one is x of n minus 2. So, these are the things you should know that. Okay. So, 3 is directly multiplied by the x of n and 3.6 is multiplied z power minus 1. So, z power minus 1 is here, I put 3.6 and another one is 0.6 into z power minus 2. So, this is my 0.6 is z power, totally it is another z power minus 2. There are 2 delays in the input side, right. Okay. Then another thing is order. So, 3 is added with 3.6 and 3.6 z inverse added with 0.6 into z. So, 2 things are necessary for, or 2 inputs are necessary for addition. Here this one. So, 3.6 z inverse plus 0.6 into z power, all are added, then we go for the output side, right. Okay. So, input side is over, we go for output side. Here output side you assume that this is y of n, or in terms of frequency domain representation it is called as y of z. Here also you see that in the denominator you also see that maximum delay element is 2. So, you just draw as like in the input side, output side is also 2 delay elements are there. Okay. Here you see that first term is 1. Okay. First term is 1. Next term is 0.1. So, 0.1 into z inverse is a feedback. You see that arrow mark is reverse. So, I put minus 0.1. Here is minus 0.1. Why I input is minus 0.1 and after the construction I will tell why the sign is changed here, minus 0.1. Then similarly another is z power minus 2 is the delay, here you put here minus 0.2 is there, so you put plus 0.2, right. Okay. Then again the denominator is also having additions are there. So all the things are added. Now the join the input side and output side. The construction for the entire filter is over, right. So here the input side is x of n, output side is y of n. In between input and output, it is called as h of z. It is your filter. It is a transfer function of the filter, right. Now I tell y. Here you see the denominator, you see 0.1 means I put minus 0.1, minus 0.2 means I put plus 0.2. Why? The reason is we want always the current output. Current output means y of n. So y of n is taken as one side, you take all the other things to the next side. So just we go to the previous page of our design. Here you see that here you see very clearly y of n is output. Here it is equal to minus 0.1, minus 0.1, here it is plus 0.2. So for that only we put, but here you see that after our simplification what you got is here minus 0.1 means here it is plus 0.1, plus 0.2 means it is minus 0.2. But for this reason we want always output y of n we have to see, right, or we want our desired output is y of n. Y of n is equal to, it is like minus 0.1 into y of previous delay is having minus, so minus in the result also, then plus 0.2 should be in the result. So for that here you see in the output side it is go to this side. So this side is y of z is there, y of n alone means this plus 0.1 is go to that side means it is go into minus 0.1, and this minus point is go into that right side means it will become plus 0.2. So that only, for that purpose only here we put. So it is the nature, right, okay, or inherent of the filter system. Okay, now we go for to design the diaphragm 2 realization. It's just diaphragm 2 realization is still very easy than diaphragm 1 realization, because it is having only less number of delay elements. Here you see that input is also having 2 delay elements and output is also having 2 delay elements. So totally 4 delay elements are required. 4 delay elements required. Okay, here 3 multipliers are there, here also 3 multipliers, but delay elements are 4. Now the delay elements, I want to reduce the delay elements into 2. Only half number of delay element is enough, but we are able to construct the filter with the same output. It is possible, right, because of another structure that is called as diaphragm 2 structure. So the output, same output is possible with the less number of delay elements. So dear students, here you understand that less number of delay elements means our time is less, memory capacity is less. Memory capacity is less means ultimately cost is less, space is less. So everybody want less number of delay elements. So we go for diaphragm 2 structure. Okay, dear students, next we are going to see about how to construct diaphragm 2 realization. So in the last session we saw that diaphragm 1 realization. Now it is diaphragm 2. It is a minimum number of multipliers. Okay, and also the delay elements. Minimum number of delay elements is enough for constructing the diaphragm 2 realization. Here you see that in the numerator is having 2 delay elements and denominator is having 2 delay elements. You see both the numerator and denominator, what is the maximum number of delay elements, that should be chosen in the center side. That is the difference between previous one and present one, right. In diaphragm 1 realization, the center side is having 2 order. Now the orders are in the input side itself and output side itself. In the center side only delay elements should be there. Then we are going to construct the diaphragm 2 realization. Now you see that here I want any change. This is x of n, and x of z is the input. Okay. So, here you put one order okay. Now, you see that input side is having one order and output side is having another order. In the center side you put the maximum number of delay elements. You see both the numerator and denominator, maximum number of delay elements is 2. So, you put the 2 delay elements in the center, right. Now, what is the difference between diaphragm 1 2 is you construct the input side in the output side and output side into the input side. The elements which are used for your multiplications are just interchanged. So, last time input side is going to the output side and output side is going to the input side. So, now I take the output side, the input side things 3, 3.6 Z inverse and 0.6 into Z power minus 2. So, that is all about the output side. Actually, the output side, the input things are I have taken as a structure and put it as it is, right. Okay. So, you take 2 delay elements and you put 3, 3.6 Z power minus 1 and 0.6 into Z power minus 2 and added everything, right. Okay. Then you take the output side. Output side should be, you may shift it to input side of your structure. So, 1 is only forward, all others are feedback. So, because it is y of n minus 1, y of n minus 2 are called as a feedback. Why it is a feedback? Y of n is the output. There is a fast output means fast y of n minus 1 is the fast output. That is feedback to your x of n and x of n minus 1 side. then only we get a current output y of n. Okay. So, feedback means the arrow mark is like this. I have already told plus 0.1 means it is become minus 0.1 and minus 0.2 becomes plus 0.2. Here also the same orders added and it can be draw like that. We got a structure for diaphragm 2 realization. So, diaphragm 2 realization is very simple than diaphragm 1 realization because only 2 delay elements. So, we know that time we are having 4 delay elements, right. Okay. Here you see that you are having 4 delay elements, input side 2 delay elements, output side 2 delay elements. So, now it can be reduced into half. So, only 2 delay elements are required to construct the filter, but the same output we got. Okay.